Hey everyone! Welcome to part 2 of my front-end optimization series. In the first episode, we talked about 10 quick wins to make your site faster. This time, we're going deeper into advanced techniques that'll make your app fly.
So here's the deal. Sometimes your website just lags. You move a slider or upload an image, and suddenly, your UI freezes like it's running on Windows 98. And that's because the browser does everything. Rendering, animations, and your heavy JavaScript, all on one single thread. Let's say we're doing something big, like squaring 1,000,000 numbers. If we do that directly in the main thread, the whole UI will freeze, nothing responds, user panics, rage quits your site. But there's a better way. Meet web workers, your personal background assistants. They take the heavy lifting off the main thread, so the UI stays buttery smooth. Watch this. I click Start Heavy Task. The spinner keeps going. Everything stays smooth. In the background, the worker's busy squaring 1,000,000 numbers. Then boom, it's done and sends the result back. No freeze, no lag, just pure performance. So how does it actually work? It's super simple. No black magic here. A web worker is just another JavaScript file, a little script living in its own world, running separately from your main code. In that file, we write what the worker should do. For example, take some numbers and square them. Then, in your main script, you just create the worker and start talking to it. You send data to it using post message. And when it's done crunching the numbers, it sends the result back. That's literally it. Just two-way messaging, like texting your background script. Hey, can you handle this? Cool, let me know when it's done. Meanwhile, your main thread stays chill. Animations keep running, buttons still click, nothing freezes. It's one of those things that's so simple, but once you start using it, you'll wonder how you ever lived without it.
Now this one's psychological. Optimistic UI updates. It's about pretending your app responded instantly, even if the server hasn't yet. Normally, when a user clicks like, the browser waits for the server to respond, then updates the UI. That's slow. Users hate waiting, even for a second.
So let's see how normal updates work. I click like here, notice the spinner on the button. It waits for the server, then finally the button turns pink. See? It feels sluggish. Every click is delayed by network speed. Now, here's optimistic updates. I click like, boom, it turns pink instantly. The server request runs in the background. If it succeeds, nothing changes. If it fails, the button resets and a small failed message appears. Under the hood, we add a liked class immediately for visual feedback. Then we send the request asynchronously. If the server fails, we remove the class and show an error. No magic, just a UX trick that tricks the brain into thinking your app is lightning fast.
This simple pattern makes interactions feel snappy, even on slow networks. Your users love apps that respond instantly.
So here's the deal. Sometimes we have tasks that are not critical for the user, like sending analytics, preparing caches, or preloading data. We don't want these tasks to block the main thread because that would make our UI laggy. And that's where requestIdleCallback comes in. It lets the browser decide, hey, I'm free right now. Let's do these small tasks.
Let's see it in action. If I click Schedule Idle Tasks now while nothing else is running, the task runs immediately, during the browser's idle time. You can see in the log the task is executed without freezing anything.
But what if the main thread is busy? I click Block Main Thread, and if I immediately click Schedule Idle Tasks while the main thread is still busy, the spinner stops spinning. The UI is blocked. You'll notice that the idle task doesn't run immediately. It waits until the main thread is free. That's the beauty of requestIdleCallback. It only runs tasks when the browser has time, so nothing blocks the user experience.
Here's what's happening in our simple example. Deadline, an object the browser gives us inside the callback. Deadline.timeRemaining tells us how many milliseconds of idle time we have left. We check that we still have tasks and there's idle time. If so, we run a task. Optional, you can pass a second parameter, timeout. That's a maximum wait time, so if the browser stays busy too long, your task will run anyway. See how it works. If the main thread is free, idle task runs immediately. If the main thread is busy, idle task waits until it's free. It's perfect for analytics, caching, preloading, or any task that doesn't need to run right now.
Let's talk about two powerful link attributes that can make your website feel much faster: Preload and Prefetch.
Link with Preload tells the browser, "Hey, I'll need this file very soon. Start loading it right now."
This is perfect for critical assets: CSS, fonts, hero images, anything needed during the initial render.
Now, link with Prefetch is different. It says, you don't need this yet, but you'll probably need it soon.
Browsers use idle time to fetch the resource quietly, caching it for the next navigation. That way, when the user clicks that link later, it loads almost instantly.
Remember when we talked about requestIdleCallback? It's a similar idea. The browser waits until it's not busy, then uses that free time to prepare things ahead of the user. So remember, Preload for critical assets you'll use right now. Prefetch for assets you'll use soon. Okay, imagine this. A user clicks a link, your page starts unloading, and you're trying to send analytics data to your server. But the request never makes it, because the page is closing and the browser just kills it.
This fetch runs too late. By the time it starts sending, the browser's already like, "Sorry, we're leaving."
Here's the fix. Meet Navigator sendBeacon, a simple API for sending small, non-blocking background data even when the page is unloading.
This one actually works. The browser queues the data and sends it reliably, even if the tab closes right after. No blocking, no waiting, no lost metrics.
Under the hood, the browser keeps a lightweight background thread that can finish sending your beacon after navigation. It's designed for analytics, telemetry, logs, anything that doesn't need a response.
A few rules. The request is post only. No custom headers allowed. Payload must be small, usually less than 64 kilobytes. No response handling. It's truly fire and forget.
So next time you need to send analytics, blogs, or goodbye events, don't block the user. Use Navigator sendBeacon. It's the polite way to say see you later to your server. So let's move on to the next powerful feature in JavaScript, something that feels almost magical. It's called Proxy. A proxy lets you intercept how an object behaves when you get, set, or even delete properties. Basically, it sits between your code and the data and lets you control what happens under the hood. It's like a secret middleman who can log, cache, validate, or even fake data on the fly.
Now, let's see something super practical. How you can use Proxy for memoization, that is, caching expensive calculations. Here I have a simple function that pretends to be heavy. It calculates the square of a number, but takes about half a second. That's our expensive operation.
Now, instead of calling this function again and again, we'll wrap our cache object in a proxy. So, what's going on here? Whenever we try to access, for example, cache 100, the proxy's get handler is triggered. It checks if the value is already stored. If not, it runs the function, saves the result, and returns it.
Next time we ask for cache 100, it instantly returns the cached result, no recalculation, no waiting.
That's the magic of Proxy. It lets you control data access without changing how you use it. You just write cache 100, but behind the scenes, it's doing logic for you.
And this is just the beginning. We can also use Proxy to make reactive UIs, lazy loaded data, or even auto-cached API calls. We'll look at those next.
All right, let's move on to another cool use of Proxy, reactivity. Imagine you have a UI with some data, like a counter, a slider, or a to-do list. Normally, if you change the data, you need to manually update the UI. But what if the UI could update automatically whenever the data changes? That's exactly what frameworks like Vue and MobX do, and you can build a lightweight version with Proxy.
Whenever we do stateCount++, the set handler triggers. It updates the internal value, calls our onChange callback, so we can automatically update the UI. All right, let's explore another powerful use of Proxy, lazy initialization. Imagine you have a heavy object, like user data, a chart, or a complex component. You don't want to create it immediately because that would slow down your page. With Proxy, you can delay the creation of the object until it's actually needed. It's like telling JavaScript, hey, don't bother loading this yet until someone asks for it.
How it works. We wrap an empty object in a proxy. The get handler intercepts every property access, lazy user name, lazy user age, etc. On the first access, it checks if data exists. If not, it creates the heavy object. The result is cached inside data, so the next access is instant. This means no heavy computation or network request happens until you really need the data.
Now, let's see something extremely practical, automatic caching of API calls. Imagine your app requests the same data multiple times, for example, user info, posts, or product lists. Normally, you'd fetch it again and again, wasting bandwidth and time. With Proxy, we can intercept every fetch call and return cached data automatically if we already requested it.
Here's the idea. We wrap the global fetch in a proxy. The apply handler intercepts function calls, fetch. If the URL is already in the cache, we return it immediately. Otherwise, we fetch normally, store the result, and return it. Next time the same URL is requested, instantly returns cached data. This means no duplicated network requests, which makes your app faster and lighter. Proxy is incredibly powerful, and there are tons of other ways to use it. Caching, validation, performance tracking, you name it. If you want me to explore more Proxy tricks and real-world use cases, drop a comment below, smash that like, and subscribe for more coding magic. Proxy is one of the most flexible tools in modern JavaScript, definitely worth experimenting with. Let's talk about CompressionStream and DecompressionStream, two native browser APIs that let you compress and decompress data directly in JavaScript without any third-party libraries. This is super handy when you want to store large text or objects in IndexedDB, save space in local storage, send data over WebSockets faster. Basically, smaller data equals faster storage plus faster transmission plus less memory.
How does this work? We create a compression stream. It takes data and returns a stream of compressed bytes. We write text into the stream. First, we encode the text into bytes using text encoder, then send it into the stream. To read the compressed data, we use response and array buffer to quickly get all the compressed content. To decompress the data, we do the same in reverse. The stream uncompresses the bytes, and text decoder converts them back into text. Finally, we output the results: original text size, compressed text size. Check that decompression returned the original text. Idea: compress data directly in the browser, less memory usage, faster storage, and quicker network transfer, whether in IndexedDB, local storage, or WebSockets.
Ever wondered why some apps load slowly on 3G? With the Network Information API, your website can adapt content based on the user's connection speed, making it faster and smoother for everyone. How it works? Downlink. This is network speed in megabits per second. Effective type. This is type like slow 2G, 3G, 4G. Check these values and adapt what you load. Low-res images or no videos on slow connections. Full content on fast connections. Here we're using the Network Information API to adapt content based on the user's connection speed. Check the current speed and connection type at the top. If the network is slow, like 3G, we pause the video and load a low-res image to save bandwidth. On a fast connection, we play the video and show the high-res image. You can even try this in Chrome DevTools by throttling the network. Watch how the page adapts automatically. This way, your site stays fast and user-friendly even on slow connections.
Web performance matters. Sometimes your page lags, layout shifts, or heavy JavaScript blocks the main thread. But how do you find the bottlenecks automatically without opening DevTools? Enter PerformanceObserver, a native API to collect performance metrics in real time. How it works? PerformanceObserver watches for performance entries in real time. We tell it to observe long tasks, which are operations blocking the main thread for more than 50 milliseconds. Every time a long task occurs, we get an entry object with properties like entry name, task name, entry duration, how long it took. You can also observe other types, layout shift, largest contentful paint, first input, etc. Idea? You can log performance issues directly in your code, find bottlenecks, and optimize them without DevTools.
Next up, BroadcastChannel API. This is super handy if your app runs in multiple tabs and you want them to communicate instantly without using a server. Here's the idea. We create a channel called App. OnMessage listens for messages from other tabs. PostMessage sends data to all other tabs subscribed to the same channel. Key point. Changes in one tab can immediately update the others. For example, syncing a shopping cart, user status, or a live counter. No extra network requests. Everything stays in the browser, fast and simple. For instance, I have two tabs of the same app open. When I click a button in one tab, you can see the message instantly appear in the other tab, and I can send updates back and forth in real time. This makes multi-tab synchronization effortless. Next up, Page Visibility API. This API allows your app to detect when a tab is inactive and pause heavy work, animations, or data processing, saving CPU and battery. Here's a simple example. We listen to the visibility change event. Document hidden tells us if the tab is in the background. If it is, we can pause animations, stop heavy tasks, or defer updates. Key benefit: your app doesn't waste resources on tabs the user isn't looking at, which leads to better performance, lower CPU usage, and longer battery life. Let's start our demo. We have a counter and a moving box. Both are updating continuously while the tab is active. Now, I'll switch to another tab, the counter stops, and the box animation freezes. Switch back to this tab, and everything resumes right where it left off. This is Page Visibility API in action. The browser tells us when a tab is inactive, so we can pause heavy work or animations, saving CPU and battery life.
Next up, Navigator, scheduling is input pending. This is a super handy API when you have long-running tasks and you want your UI to stay responsive. When we click Start Heavy Loop, a long loop starts running, thousands of tiny steps. Normally, such loops would freeze the page and block user interaction.
Inside each step, we simulate work with a small delay. This represents a CPU-heavy calculation without doing anything real. Before continuing the next step, we check isInputPending. This tells the browser, hey, the user is trying to interact. Pause the loop for a moment. If input is pending, we pause with await not task equals word.yieldEvent. This gives the browser a chance to handle clicks, scrolling, or typing, keeping the page responsive.
When we click Click Me while the loop runs, the page reacts instantly and logs. The loop then resumes automatically after the browser handles the input. This method allows long-running tasks to coexist with user interaction. Without isInputPending, the UI would freeze, making the page feel unresponsive.
Let's move to another modern API, the Scheduler API. It's a more powerful alternative to setTimeout or requestIdleCallback, letting you schedule tasks with priorities. Web apps often have multiple tasks happening at the same time. Some tasks are critical for the user, like updating the interface instantly. Other tasks are background work, like logging or preloading data. Without prioritization, background work could block the UI. In our demo, we schedule tasks using the Scheduler API. User blocking task runs immediately, updating the log so the user sees results. Background task waits for idle time and runs later, without slowing down the interface.
When we click Run Tasks, first, messages from user blocking tasks appear instantly in the log. Then, background tasks execute one by one, only when the browser has spare time. You can see the difference in the order they appear. Benefits: smooth, responsive UI even with multiple tasks. Background work doesn't interfere with user experience. Easy way to manage task execution priorities using a modern API.
When you have large DOM fragments, like lists of cards, modals, or complex components, rendering everything at once can slow down the initial page load. We want fast first paint without blocking the user. HTML template allows you to store HTML fragments in the DOM without rendering them immediately.
For example, this content stays invisible and doesn't impact layout until we insert it.
When we need it, we can clone and append it. Here, clone node copies the template content, and append inserts it into the visible DOM.
We can do this on scroll, on interaction, or after the main page has loaded. Benefits: reduces initial DOM size, faster first paint, keeps page responsive. Great for lazy loading UI fragments like cards, modals, or dynamic lists.
We've explored a bunch of modern browser APIs. These tools let you keep your UI fast, responsive, and efficient, even under heavy workloads. If you found this useful, drop a like, leave a comment, and subscribe for more deep dives into web performance. See you in the next video.